Hello, my name is Rasmus Grip and I work for the company Ranotor in Sweden. We're currently engaged in a European Union project called Hypergryd. Hypergryd aims to rationalize the energy production and consumption of electricity as well as district heating and cooling. Ranotor has a long history of research and development, and we're currently designing an engine that runs on externally applied heat. Therefore, it can run on almost any fuel, including biofuels. Most engine uses the fuel inside of the engine to create explosions. Therefore, they are optimized for just one fuel source, like diesel or petrol. Our engine can also run on waste heat, for instance from industrial processes that generates a lot of heat, or heat generated in plain solar collectors. The purpose of the engine is to produce electricity and heat. A regular home requires both electricity to run appliances, but also heating and hot water. Our system can be integrated within the power grid or to be used as a standalone utility. Since the combustion is external in our engine, it produces far less emissions and dangerous particles. And maybe more important, it can run on clean energy sources and produce electricity in a carbon-neutral way. 70% of the world's electricity is produced in power plants within a steam cycle. Power plants are basically a really big hot water kettle that turns water into steam. We use the same steam cycle but in a smaller scale, suitable for houses and residential areas. It can also be used in more remote locations to where the power grid don't reach. The engine system produces heat and power on demand, but it also has an energy storage. The energy storage system that we have developed is much like a battery, but instead it stores heat. Therefore, it can produce extra electricity and heat when there are peaks in the consumption. For instance, when everybody come home from work and start cooking and watching TV. The storage can also be utilized to store energy when the electricity is cheaper than the fuel, for instance when the wind is blowing. Therefore, it can be used to even out the differences between supply and demand. What's most technically challenging when designing a small-scale steam engine is material choices. Therefore, most of our efforts are concentrated there. But also to make certain that the combustion is as clean and efficient as possible. Combined with the other enabling technologies of Hypergryd and the smart governing of the electric and district heating system, we hope to produce something that lowers the climate footprint as well as meeting the current and future challenges ahead. Thank you for listening.